We're starting now the final topic in our percent unit, and that is a concept called percent of change, which is something that you see in the news or in science and in economics and all kinds of places, very often reported that something has changed by such and such a percent, increased or decreased by a certain percent. And that is called percent of change. Okay, so we start on page 143 with a look at the Indy 500, which is a race car race. Okay, and this table here shows the speed, the average speed of the winning car. In 1922, that average speed was 94 miles per hour. In 1955, it was 128 miles per hour. And in 2010, 162 miles per hour. Okay, so obviously the speed's getting faster as the cars get better and the technology gets better. Then the cars drive much faster. All right, so it asks you to write two ratios here. The first one, the increase in speed from 1922 to 1955. So to find that increase, you subtract these two numbers. Okay, so from 94 up to 128. Okay, that difference is 128 minus 94 is 34. Okay, and you divide that by the 1922 speed, 94. Okay, so 128 minus 94 is the change. That's the thing at the top here, divided by that speed in 1994. And what is the percent of this? What is the percent? So 34 divided by 94, that comes out to 0.36 or 36%. 36%. Okay, so that means that the speed increased by 36% from 1922 to 1955. All right, so let's see what happened from 55 to 2010. Well, subtract the values again. 162 minus 128, and that again comes out to 34. But this time, we're dividing 34 by the 1955 speed, 128. So when I do this division, the answer in my calculator is 0.27, and that means 27%. So notice that in both of these situations, even though the amount of change was the same, the increase was 34 miles per hour, the percent of increase was bigger from 22 to 55 than it was from 1955 to 2010. Why is this? Why are the changes the same, but the percents are different? Yes, the answer is because the whole number amounts, the speeds that you are using as the whole, are different, right? The change in the first one uses 1922 speed as the whole, and the second one uses the 1955 speed as the whole. Okay. Now, people can mess with these calculations, and depending on how you report them, you can do all kinds of things with statistics and which numbers you use. So understanding this stuff, again, helps you understand where some of those things come from. Okay, so percent of change is a ratio, and it compares the change in a quantity to what it started at. All right, so when you compare the amount of change to the original amount, you're finding the percent of change. Okay, if the amount goes up from the original to the new amount, then it's a percent of increase. And if the amount went down from the original to the new amount, then it's a percent of decrease. Okay, so the way I do these, okay, so the amount of increase or the amount of change divided by the original amount, and then that gives you a decimal answer. And so if you multiply that by 100, you'll get the percent. Now, this multiplying by 100, of course, is just moving the decimal point 2 places to the right. So you can either do times 100 in your calculator, or you can move the decimal point 2 places to the right to convert decimal to percent. Now, you could do the new minus the original, okay, except for if the original is bigger than the new, if the actual amount went down, then when you do this subtraction, you get a negative number. We haven't gone over negative numbers yet, so we're not going to work these problems quite with this specific rule, even though it tells you whether it's an increase or decrease. We'll just identify whether it's an increase or decrease and use the amount of change. That's what the book does anyway. All right, so here's gas prices, 1970 and 2010, from $1.30 to $2.95. Okay, so what is the percent of increase? What is the percent of increase in gas prices from 1970 to 2010? Well, the price went up, so it's an increase. Okay, and the amount of increase is a subtraction, the difference between these two numbers. You subtract them, you can use your calculator for that, and it's $1.65. So the price went up $1.65. That's the amount of change, or the amount of increase. We divide that by the original amount, which was $1.30. $1.65 divided by $1.30 comes out to about 1.2692, blah, blah, blah. Okay? So it's not a decimal, but it is a decimal. Okay? Because we still multiply this by 100, move the decimal 2 places to the right. This comes out to be about 127%. 127%. What does that mean? Well, it means the change, since it's over 100%, means the change is more than the original value, right? If it went up by 100%, then the change would be $1.30. Okay, so the amount of change is actually greater than the original amount. That means it's more than 100% of change. And in fact, in this problem, it's 127%. When you give your answers here, you must say the word increase or decrease. So what was the change in price of gasoline from 1970 to 2010? It was 127% increase. Okay, so yeah. You change the decimal answer to a percent when you do the division of change divided by original. Another example, you bought a DVD recorder for $280 and now it's on sale for $220. What is the percent of change in price? Round to the nearest whole percent, it says in the directions. Okay, so we find out how much the price changed. It went from $280 to $220. It was $280, now it's $220, so it went down by $60. That's the change or the decrease in price, $60. To find the percent of decrease, we divide $60 by the original price, which was $280. That comes out to 0.21428, blah, 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 blah. But it says to round to the nearest whole percent. So we move the decimal point 2 places, and this is going to give me 21%. So again, the price is a 21% decrease. The price went down by 21%. You have to say increase or decrease when you're stating a percent of change. All right, here's a couple of got it problems. Find the percent of change from 10 yards to 13 yards. 10 yards to 13 yards, what's the percent of change? We start by finding the amount of change and was it an increase or a decrease? It went from 10 to 13. That's an increase in 3, an increase of 3 yards divided by the original amount, right? So it's the amount of change over the original. That's how you calculate percent of change. Always change divided by original. Okay, or in this case, the decrease divided by the original. So in your calculator, what is 3 divided by 10? You shouldn't even need your calculator for that one. 3 divided by 10 is 0.3, or 3/10 is 30%. Okay, but did it go up or down? It went up, right? It went from 10 to 13, so it's a 30% increase, 30% increase. Letter B, a radio was $20 and now it's on sale for $15. What is a percent of change? This is really finding out what the percent is, right? What the sale percent is. It was 20, now it's 15. What percent change is that? Well, the amount of change was $5. It went down $5. Right? You don't have to write out the subtraction if you don't want to. It's a $5 decrease in price. The original price was 20. So 5 divided by 20 is 1/4 or 0.25 or 25%. And since the price went down, it is a 25% decrease. So this radio was on sale for 25% off. They didn't give you that in this problem. They gave you the original price and the sale price. So if you wanted to, you could use this method to always find what the percent off is. Kind of skipped those problems in the last unit. So 30% increase and 25% decrease are the two answers there. All right, let's take a look at two more problems here in the guided practice, page 146, and then we'll do some practice. So find the percent of change. Round to the nearest whole percent. State whether it is an increase or a decrease. From 30 inches to 24 inches. The amount of change is 6 inches, a decrease, divided by the original, which was 30, the old number. 6 divided by 30 is 0.2. Change 0.2 to a percent, 20%. It's a 20% decrease. 20% decrease. From $126 to $150. The amount of change is $24. 150 minus 126, $24, and divided by the original amount, which was 126, the old amount. 24 divided by 126 in your calculator, 0.19, blah, 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 blah. But we're rounding to the nearest whole percent. So that rounds to 19%. And this is an increase because it went from 126 to 150. So it's a 19% increase. And that's percent of change. Find the amount of change by subtracting the old minus the new, whatever the increase or decrease is, subtracting the two values, and then dividing by the original value. That's the most common mistake people will make, is that they will divide by the new value, right? If you put 150 under here, you would get a different percent, right? The whole, what you divide by is always the original value, always the original value. There you go. So now we'll work on some practice problems.